All right, want to thank everybody for coming on our webinar today. My name is Kenton Sonnenberg. I manage the equipment department with CHS. With me today, I've got Ryan Zick from Roush, and he's going to show you a whole bunch of really good information on growing gallons with school bus fleets. With that, I will hand it off to Ryan.
Okay, thank you very much. I appreciate everybody jumping on the webinar today. Today, I want to walk everybody through, as we just said, the opportunity that exists really partnering with CHS providers along with Roush Cleantech in the school bus fleet industry. So there's a big opportunity for us both, for us to sell vehicles and for you to sell and grow your gallons. And there's a great synergy between the two. So before we start, I just want to share a little bit of information on who we are and how we fit into this whole thing. So Roush Cleantech is a business unit within the bigger Roush Industries. Overall, as Roush, we are a large OEM automotive engineering firm. So really our foundation is very much founded in major automotive manufacturing and engineering, but that is probably the least visible part of our business, although it's the biggest. We're also really well known for Roush Fenway Racing, which is a NASCAR sprint team. Roush Performance that does a lot of performance vehicles like the Raptors, the F-150 Roush version, the Mustang Roush version, all of that. And then Cleantech is the newest addition to the family. And we started back in 2008 doing propane autogas systems at an automotive OE level. And really, we started out in lighter duty and then really found a great fit in what we call class 4 through 7 vehicles, and that is where school bus fits into and what we're going to spend a lot of time talking about today. So that's really how we fit into this whole alternative fuel world and where we got our start. If you look at what we do as a company and how this all comes together, the idea is that we can take a product from a basic concept or design, and if we're looking at propane, we can go back to that and we can say that in 2008, there was still a lot of vapor technology on the market. And through PERC and some other people, we had interest in someone developing a propane autogas fuel system that was going to be at automotive level. And from that, we took that concept and that design, we did engineering validation, we created parts that we still make today and engineered them, and then we validated them, and now we have them out in the field and we're servicing them. But we can do all of that within the greater organization that is Roush, so that overall Roush Industries. And to give you an example of that, we created a dedicated liquid injection fuel rail for the propane system that we designed, we engineered, we validated, and that we even CNC machine here on site for use in the propane autogas system that we use today on the school bus and the class 4 through 7 trucks. So if you would, before we jump into the opportunity and working together and what our go-to-market strategy would be, I'd like you to kind of take a step away from, kind of your mindset and what you do today and try to put yourself in the shoes of the school district. So maybe a transportation director or a business manager, superintendent, even a school board member, and maybe some of you already are school board members. So try to think of it from that point of view. And I want to walk you through some of the material that we share and find valuable as feedback even from our existing users on why they're going propane, why they're using it, why they're having success with it, why it's one of the most loyal fuel types that's out there in the industry. So let's go a little bit on the product side and those types of things. So if we look at how this fits into the school bus landscape, Roush Cleantech is exclusively partnered with Bluebird School Buses. So it's a three-party partnership between Roush Cleantech, Ford Motor Company, and Bluebird. So when you talk Roush on the school bus side, it is only going to be associated with a Bluebird school bus. And on the screen there, you'll see the Bluebird Vision, the larger type C bus. And then you'll see the Bluebird Microbird, which is the smaller type A bus next to it, which we have a complete offering on of all types and configurations for those two vehicles with our propane autogas system. So when you have a fleet today, looking at the choices that are out there in school bus for fuel types now, this is representative of all of them. So there's diesel, of course, that has been the staple in the industry for the past decade or more. Gasoline is also available, propane, of course, compressed natural gas, and electric. And when we go through this matrix to find out what's most important to our fleets and how do the different fuel types stack up and basically meet the needs of what they have, we find that propane actually does a better job than not only the other alternative fuels out there, but a better job than the traditional fuels that they're used to operating. And some of those key metrics that we looked at when we're looking at what to invest in, and at the time, CNG was really was the big popular fuel type that was going to be the next frontier for all sorts of medium duty transportation. And we found that not really be the case, and that we've had considerably more success than CNG with propane. And this is why, if you look at all the things that are important, right? The fleet has to be able to run in cold weather conditions like we're having today in Michigan, right? Single digit weather. We've got to be able to start up and run. We can't have any adverse effects there, and it does a great job with that. You have to have ease of adoption into your fleet. So we can't have all kinds of special tools or upfit bays or bring in expensive new infrastructure to be able to operate the fleet. Sure, gas and diesel check that box, but CNG and electric, your other alternative fuels, not too easy to adopt. There's big changes that need to be made. Propane, not the case. NOx emissions and overall emissions output. Yeah, the other alternative fuels do a good job at that, but propane does an excellent job at that. We're actually able to reduce the current federal level of NOx emissions by 90% with our new propane school bus. Cost of ownership. This was a huge thing for Jack Roush. When we talked about getting into the alternative fuel space, everything's great from an emission standpoint and from going green and using domestic energy sources. But the fact of the matter is, at the end of the day, if it doesn't make economical sense for a fleet to do, they're not going to do it. They're going to rely on grants and things like that to be able to buy alternative fuels. And propane, that is not the case. Most of our success in propane has come without the aid of any grants or incentives. The fuel stands on its own from an economical standpoint. Range is another really big one. You know, a fleet has to be able to cover so many miles on their routes without having to refuel either in between routes or every single day. And electric and compressed natural gas are very much range restricted. Propane, you're going to be able to go pretty close to 400 miles on one tank on our larger tank offering on the Bluebird Vision school bus. So it is very close to on par with expectations of gas and diesel buses. So once again, we don't believe that a fleet should have to change what they do to accommodate the fuel, but the fuel should accommodate their operation. And that's what propane does a great job. So moving on to where we've had success with this fuel in North America, you can see what I alluded to earlier, that we're not only having success with propane school buses in areas that have traditionally been heavy on funding. We've also had great success in places that have had zero funding. A great example of that would be the entire country of Canada, and then most of the U.S. Central, Midwest, and Southeast portions of the country. So we've actually had tremendous success here in Michigan, Wisconsin, Iowa, Minnesota, Nebraska, all those different places. We've got hundreds and hundreds of units, and in some areas up over 1,000 units in deployment already. But what this also shows is that we've got the experience and the success stories to show you of all different climates of operation. So from high altitude applications of Denali National Park and the Rockies of Colorado to Mesa, Arizona, some of the hottest parts of the country, you know, all the way up to some of the coldest deployments, which is one of our largest up there in Alberta, over 500 units running in very, very cold conditions, outperforming the diesel counterparts consistently in great cold weather performance. So it's a great way to really look at what propane can be for a fleet and how much it can help, not only from a going green standpoint or a saving money standpoint, but also from just a day-to-day operation. It just simplifies and streamlines the school bus fleet operation. So if we dive a little bit deeper into the powertrain of the vehicle, the foundation is a Ford 6.8 liter 3-valve V10 engine. It is the current Super Duty engine platform that Ford uses for their own vehicles, and it is line built at Ford's Windsor engine plant to run on propane autogas. This would be a huge differentiator from any other alternative fuel platform, especially on propane, that we've seen. Ford is an active partner in that three-part partnership that we talked about between Ford, Roush, and Bluebird. So when they're line building these engines, they know specifically that this will be a V10, not only built for Bluebird, but it's also built to run on propane. So they're going to do things throughout the engine to make sure that running on a propane or a gaseous fuel, that there's going to be absolutely no issues with the reliability or longevity of that vehicle or that engine through the entire life cycle, as you would expect out of it. So that is a huge benefit that we get from working with a major OEM partner like Ford Motor Company. We also benefit from a lot of the key in-process checks that they use that you can't get from smaller engine builders. So when they go through and build these engines, they select fit all the components for it. As you can see there, there's barcodes that are on top of the pistons, and they select fit those with micrometer measurements to cylinder bores to make sure that it's built up exactly right. And they document that throughout the entire process. And that's something that you can't really get, or we've never seen in the alternative fuel space. Usually you've got smaller manufacturers doing what we call stall builds, using tools like click style torque wrenches and things like that. And they don't have the control processes that a major OEM like Ford would have. So I talked about line building specifically for propane, and one of the ways that they do this in an important way is that the valve train of the engine is made out of a super alloy called Inconel, which has really great resistance to low lubricity applications. So propane, as you all know, has a lower lubrication factor than a gasoline. So in order to make this engine and the valve train of it completely resistant to running on propane from day one, hour one, mile one, all the way through to its complete life cycle, they change parts out throughout the entire engine to make sure that it is designed, built, and coated for propane autogas. The engine is mated up to Ford 6-speed transmission. This has been a really fabulous transmission for us, and the great benefit is that typically in the medium duty and specifically school bus space, you'll have one engine manufacturer building to power a transmission by another manufacturer, and then they'll have two control modules trying to talk to each other. And some of that can be a little bit complicated when it comes to warranty and troubleshooting. Great part about having a complete Ford powertrain is that you have one brain controlling that entire power pack. So it simplifies and streamlines diagnostics, and it also simplifies and streamlines the warranty process. So the big thing and the biggest driver that we see pushing people toward, and school bus fleets specifically, toward propane autogas versus the traditional fuels are these two things: cost and complexity. Those are the big drivers. The side benefits of the environmental aspect, buying a U.S. domestically based fuel, all those are great and important benefits too. But this recurringly seems to be the main driver for people to shift focus and away from traditional fuels like diesel. So what's going on with the modern diesel today? You all on this call are probably pretty familiar with it from your medium duty trucks, but diesels are not getting any simpler. They're getting more and more complicated as time goes on. They require additional tooling and training almost every year, every time they have a cert increase. And then there's also big challenges with the school bus duty cycle. So a school bus spends most of its time at idle. So we go from stop to stop, pick up, drop off, drive a little bit, and stop again. And that is the hardest thing for a modern diesel to do. And the reason why is that the catalyst that controls the reduction of NOx and the diesel particulate filter, it wants to be at a steady temperature with a heavy horsepower use. And that's where it ideally functions. So when you let it idle and you let the catalyst cool, it gets very inefficient, which causes it either to plug up the DPF filter or to get out of compliance on NOx and derate, all of these different things. And obviously, when you've got a busload of school children, the last thing you want is for your diesel engine to be derating where you're going less than 5 miles an hour on the side of the road with a load of kids. So it poses a pretty precarious situation. You won't have any of that when you get into the propane side. So school districts find that refreshing. So the complexity on the diesel side is driving one side of the cost. The other side of the cost is being driven by the fuel component. So throughout, if you go back, this goes back to 2015, but you could even look back even further. Typically, propane tracks somewhere around 40% lower than your diesel fuels. In some cases it's higher, and in some cases a little bit lower, but that's a pretty fair trend going back into to 30 years ago or so. So that's where the other piece of your savings comes from. It's from the fuel side. We've got a lower cost fuel, and we've got a simpler system with less repairs required. And over that, we can really compound and save a ton of money for the school district. Preventative maintenance is absolutely another one. As the exhaust gas recirculation requirement has increased on the diesels, their oil capacity has had to increase as well to make sure that the oil stays clean enough for the change interval. And so you can see there the pile of oil, 17 to 30 quarts on the diesel with a really expensive oil filter versus the 7 quarts required for the Ford V10 with a Motorcraft spin-on oil filter, which typically costs right around $5. Also, the oil, pretty basic. It's a 5W30. So nothing special in terms of an alternative fuel oil or anything like that. The standard oil that Ford prescribes is what we also recommend. So there's some other operational considerations and benefits when you get into propane too. So a little bit about cold weather, but diesels also require manual regeneration. So when you get out and the bus isn't doing a long enough duty cycle or hard enough duty cycle, the diesels will require regeneration. So some fleets will actually send a bus out on a normal school route. It'll come back to the bus garage, and then they'll send it out empty with a driver to do a highway run to try to get its emission system back in running order. So they're paying a driver, they're wasting fuel, they're racking up miles on the vehicle to try to accommodate the emission system that's on it. And people are getting tired of it, and I absolutely would be too, that you're depreciating your vehicle just trying to get the exhaust system to work properly. Electric block heaters, that's another one. We offer them on the propane school buses, but even our coldest conditions where they leave them outside, they say that the buses heat up so quickly and start so well unaided that it's really a waste of time to plug in the block heater, because propane performs, liquid injection propane, I should say, performs so well in extreme colds. Webasto heaters, these would be heaters that are fired by diesel fuel, and they circulate hot coolant throughout the vehicle while it's shut off. No need for those. Those are expensive units. Those are over $3,000 a piece that some fleets are putting on their diesels to make sure they'll start up in the cold weather. Fuel blending and additives, you don't have to worry about that with propane from the traditional standpoint of diesel number 1, diesel number 2. What time of the year should I start to change? When should I blend? All of that stuff goes away with Propane Autogas for these fleets. And then labor costs. We've got some customers that will send people in and get the buses going hours and hours before the routes will start to make sure that everything's going to be up and running. And if not, they'll pull them around, put them inside the bay, let them warm up and get them going. And we've been able to reduce and eliminate that with propane school buses. And then also idling the buses in cold temperatures, wasting fuel and putting out emissions. We don't have to idle as much or hardly at all when you talk about propane school buses because of how well they heat up and maintain heat. Reducing your inventory of parts is also a big benefit of it. So I'm sure we're all familiar now with diesel exhaust fluid. You can see the 275-gallon tote that has become commonplace to see at a fleet garage. We get to eliminate all of that. So not only the extra jugs of oil, but the extra jugs of diesel exhaust fluid. And you don't have to worry about a driver accidentally putting DEF in your diesel tank and having to drain the whole thing. But you know, the average diesel school bus takes a little over 40 gallons or so of DEF a year. So it's not tremendous in terms of the consumption of it or the cost of the fluid itself. It's really the complexity of that tank and all that wiring that you see there in the picture more so than the nuisance of fueling up an extra tank. So if you add that together with a lot of the other components that you see, we can really eliminate the complexity on the school bus for a school fleet. So there you can see all those different things that become a huge cost burden, along with a burden of downtime that goes along with the school fleet. So the air-to-air cooler, EGR cooler, turbo, and then those extra canisters that help to keep everything in line from the standpoint of NOx emissions and then also particulate emissions. All those different things are working, and it's an active emission system. So what that means is that if it gets out of compliance or isn't working properly, it will derate your bus. So that means it'll take all your power away. It's going to go into a limp mode until you get it back to the shop and repair it and get it running properly. So you can't ignore these things either. So when we look at the
Hey, Ryan,
specifics of the, yes,
quick question for you. I just had one
yeah.
that kind of popped up, and I thought we might as well just talk about it right now. One of the questions was how much less mileage versus diesel fuel? And then I have one
So
other question.
yeah,
Can I park buses inside? So if you want to handle those just real quickly, that'd be great.
okay, yeah. So for the first one, mileage versus a diesel, you're normally going to be somewhere around 65% of what the diesel fuel economy is going to be. So even round numbers, if a diesel on the exact route is getting around 10, the propane would get around 6.5. The truth is closer to a diesel gets about 7 on a route today, a school bus route, and a propane gets somewhere around 4.5. That's a pretty round average for all of North America. Now, of course, the route's going to drive some of that. So if you have a high idle, very urban route, that's going to go down. If you've got more of a rural route where the vehicle is running open more, then you're going to have obviously higher fuel economy. And it just kind of varies that way. But that's a good way. Usually you're baselining it against a diesel school bus. So that's a great compare and contrast. For the second question, bringing school buses inside or parking them inside, storing them inside, it always goes back to the local fire marshal or what we call the authority having jurisdiction, which is typically the fire marshal. Across the board, I'll say that we have lots and lots of fleets that bring them inside for obviously service, but also storing them overnight with absolutely no issues. And they've had to make no modifications to their facilities. So that has been pretty much the standard of what we've seen. Have we seen certain areas where the fire marshal has said, you can do this, but we ask that you put in a sensor of some type, or we ask for you to do something with your ventilation? Yeah, we've seen that too, but it has been pretty much the exception rather than the rule that we have seen those types of situations where typically if you're able to store a gasoline or diesel vehicle inside, you're also able to store a propane inside since the fuel follows the same path of being heavier than air, just like gasoline or diesel fuels. Okay, we'll continue on. So getting into preventative maintenance, and this really is the breakdown of the cost between the two. So on the top, you'll see what's representative of our propane engine, and on the bottom, you're going to see what's representative of a Cummins 6.7, which is the standard in the diesel world for a school bus today. So if we just look at preventative maintenance, air cleaner, oil filter, the quarts of oil by quantity, same thing on the diesel side, see about $71 versus $278. And believe it or not, intervals are pretty close to the same, might be a couple thousand miles different. So on the preventative maintenance side, not too far off, nothing earth shattering, but there is a savings there. Where we really get into a lot of the expense is what we call the ancillary devices, or all the components that make up the emission system today. So on a propane engine, we're starting with a cleaner fuel, and we're having to do less to it to make sure that it not only meets, but actually exceeds emissions requirements. So if we look at the propane, we've got a vapor management valve, positive crankcase hoses, really simple stuff, the gaskets. We've got the fuel injectors. So you might think, oh, liquid propane fuel injector, that has to be an expensive injector. Not really. We do have 10 of them. It's a V10, but they're only $215 a piece and have next to zero for a failure rate. So they've been an extremely robust item for us. It's not something that you commonly have to replace at all. The catalytic converter, which makes up the bulk of the emission system, that's $910. The spark plugs, which are your standard Ford spark plug in this application, somewhere around $70 for the full set, and then the O2 sensors. So you look at that and you want to replace all of those items all at once, it's going to be about $3,350. So if you want to compare that to the diesel, we'll look at that next. So now you see NOx sensors, right? We have that active emission system, pressure sensors, the diesel exhaust fluid doser, the one-piece catalyst assembly, which would take the diesel exhaust fluid and inject it into the exhaust stream, and then also try to trap the particulate matter at the same time. Look at the cost on that. That unit's $10,500 by itself. And for the most part, without exception, that's not going to make it for the life of a school bus just about anywhere in North America. You're going to have to do something to that at some point, and maybe multiple times, which has typically been customer feedback. Temperature sensors, turbo, that's an expensive item. And then fuel injectors, you compare that to a liquid propane injector, and a diesel injector is actually about 10 times higher in the pressure that it's dealing with. Also a lot more expensive in the cost. So there's only 6 of them, but they're $755 each. So that creates a big price tag there as well. And then your EGR valve and cooler. So if you compare our $3,300 compared to the ancillary devices on a diesel, $21,000. So this is what's really crippling school bus fleets, that they have finite resources. And when they're trying to keep a vehicle up and running that has these kind of price tags associated with the exhaust system, it can be catastrophic, where you're really straining your resources to be able to keep buses running because of all these things. And you can't delete them, you can't get rid of them. If a check engine light comes on, you have to address it, especially as a school district, right? They scrape your inspection sticker, and then you're down until you correct it. So all this stuff has to be addressed in real time. Inevitably, we get the question though, but diesel engines last a really long time. What if the V10 doesn't make it the full life cycle of our vehicle? The answer is that we've got customers now with school buses that have over 150,000 miles with absolutely no issues with this engine. So we have every belief that through Ford's engineering validation and now real world customer experience, that this engine is going to make it the life of the bus without a problem. Even if we said, okay, let's say an engine fails, what does that look like? So if you look at the Ford engine, you're going to be able to replace that for somewhere around $8,000. Now, if you remember, just the exhaust components on the diesel and the emissions part was $21,000. Now, if you look at the base engine, that's another $19,000 on the diesel side. So even if you have to replace an engine completely at some point during the life cycle, just a turbocharger can set you back almost that much. And this would be the most expensive option for replacing the engine. This would be a fully dressed long version. If you wanted to do a short block version, because the Ford is a major OEM engine and there's been so many produced for over 20 years, you could get a short block version, you get reman versions, and the price could very easily be half of what we're showing here. But we want to show worst case scenarios. So this is how we're helping fleets streamline their operation, reduce their costs, reduce their burdens, and better manage their budget. Because when a turbo goes out, that's a huge chunk of change you weren't planning on. But if it doesn't exist, it can't fail on you. So here's what our actual customers are telling us in feedback. These are people who've been running propane from anywhere from newer users to longtime existing users. We wanted to share a variety. So Clear Creek ISD in Texas, they're running quite a few. They probably have close to 100 of these. They say that we're saving 15 cents per mile on average. If you look at the next district next to it, which is Crestwood, they're saving 34 cents per mile on average. Now, what's the big difference? Why 15 cents in Texas and 34 cents in Iowa? The big thing there would be that it's hard to buy diesel anywhere cheaper on planet Earth than Texas. So that is why you would have such a low cost of operation on their diesel buses too. But even with that, even with the best diesel prices you can get, we're still saving 15 cents per mile with the propanes versus the diesels. Go over to Iowa, and diesel is more representative of the nationwide average for price, and propane is also. So you're looking at that and closer to 34 cents per mile. Now this would be with fuel, this would be maintenance items, everything all included in these. Upper Moreland schools, so that one's out east, so we're getting a good sample all the way across the country. Over $7,000 per bus in savings in their first year of operation, propane versus the old diesels. So big savings there, huge. I mean, they're getting their entire payback for the amount. The school bus was more expensive than a diesel up front. They've already made back their investment in year one. And then Cook Illinois Corporation, a large contractor in Chicago, Illinois, 80% lower fuel costs by going to propane than running diesel buses. It's huge, and they will tell you that their number one expense as a fleet is fuel. So huge savings for customers. And then there's also the environmental benefit. And we don't want to understate this in any way, because when you're talking about a school bus, the students that you have on board, the amount of time that they spend on it in loading zones and sitting at stops, the cleaner the better across the board for these people. So California Air Resource Board established a couple different metrics to try to get manufacturers to certify engines to lower NOx standards. And NOx is really this harmful emission that comes out of tailpipes of internal combustion engines, whether you're talking about diesel, gasoline, or any others. And there's certain ways to manage it, and there's a federal level that prescribes it that we can't be over 0.2 today. But California Air Resource Board said we're going to create a couple other stair steps down to encourage people to pursue these and make the engines cleaner. So they prescribed at 50% lower, 75, and 90% lower. And today we are the only propane engine that meets an optional low level. And in fact, we meet the lowest level, so 90% lower than the federal standard. There's no other propane, diesel, gasoline, or anything else that meets that in the school bus Type C market, with the exception of CNG on a rear engine. So we are really at the lowest possible limit for that harmful tailpipe emission, which is really important to school districts and transportation directors. What we've also seen, and we received a study from West Virginia University, which compared in-use testing. So even though diesels have a lot of campaigning around them today that they're clean diesel, what we found, and this really goes back to that catalyst wanting to be on an over-the-road truck and not a school bus, is that when you put one of those vehicles in a school bus duty cycle, the propane actually performs cleaner than certified, and the diesel actually gets out of compliance because it allows the catalyst to cool and it's idling too much. So even though we certify to a certain standard, when you put us in a school bus duty cycle as a diesel, we're reducing NOx by over 96%, and we're even reducing CO2 as compared to a diesel, which diesels are typically really great at CO2. But once you start looking at the real world duty cycle, it's not necessarily the case. The infrastructure piece too, and this is a huge part of where CHS partners come in, is that propane infrastructure is really impervious to, the EPA and contamination of groundwater and all that stuff that is regulated around underground storage tanks for diesel and gasoline. And we have had school bus fleets that have come to us to say, hey, we just got hit with a $1 million fine because our diesel tanks were found to be leaking in some way. And now we've got to dig them up and we've got to remove all the soil around it. And all that mitigation is going to cost us a fortune that we don't have. So we're going to propane. So we're expanding our fleet to propane because we don't have any of those requirements once it gets into propane. If it leaks, it's non-toxic, non-carcinogenic, it can't contaminate the groundwater. So whether you're burying it or keeping it in an above ground tank, they're really much more ready to manage the risk going forward, because when you bury those tanks, you're burying them for decades. And school districts are around for decades, so there's really no change there. And going to a more resilient fuel that way is really beneficial for this. So fueling is also something that always comes up when you're talking to a school fleet. And it's really, I think, just kind of the unknown of how do you do it. And really, the propane industry has done a great job of making fueling not only better in general, but better than the traditional fuels. The picture that we showed there is a Staubli nozzle or the Euro Quick Connect. So that would be a single hand operation, very much like a pneumatic air chuck type, where you would be able to connect the fitting, transfer fuel with one hand, no personal protective equipment, and release it from the nozzle without any threading on like the traditional Acme 1 3/4. Bluebird offers both designs today, so the standard is still the 1 3/4, and there's an optional feature for the Staubli or Euro style. And we've seen a huge migration from customers from the 1 3/4 over to the Staubli. So that's been great to see, and we've gotten feedback from customers too that have adopted propane that have thought that having their driver's fuel was going to be the biggest obstacle that they could have. And really what they found is that drivers, once they start getting used to fueling propane, they won't go back to fueling diesels. And that's because the diesel has a residue that it leaves on the ground. It gets on their hands, they track it into their own vehicles, and then they can't get rid of that smell. Whereas with propane, there's absolutely no residual. So that's a side benefit that we didn't really account for. And propane is actually better in a lot of ways than fueling a diesel bus. Not to mention, your driver's not exposed to a percentage of diesel fuel. Safety is absolutely paramount when we're talking about school buses. So there's a lot of things that Bluebird and Roush do to make sure that we're going above and beyond to make sure what we offer is the safest fuel type that you can get on a school bus. So there's a lot of features, and I don't think I have to tell this group about the nature of propane itself, and that it's actually a very docile fuel to work with from a fuel system standpoint, that it's contained and managed very well in very dense tanks. But the tanks themselves are 20 times more puncture resistant than what is used in a gasoline or diesel tank. So extremely strong, extremely thick, and a lot of safety features built in well above and beyond anything that's offered on a gasoline or diesel engine. So we've got shutoffs built in throughout the system that are both electrical and mechanical that have redundancy features to them. And then, of course, all of your NFPA guidelines are met and in a lot of ways exceeded. So Roush doesn't have to build with stainless steel fuel lines per guidelines, but we only use stainless steel or stainless steel braided material when we're outside of the fuel tank. So from our supply lines to our lines, we try to use the best, most robust material possible with the amount of safety features that we think is acceptable for a school bus, which is the most that we can have on there, really. So great fuel to work with from a safety standpoint, whether you're the technician, whether you're the riders, the drivers, you have an extremely safe fuel to be around and operate. And then, of course, the school bus, even though it's over the weight limit for medium duty vehicles to crash test, anything that is a school bus has to be crash tested as a complete vehicle. So Bluebird crash test to the more stringent Canadian motor vehicle safety standards, which is tougher than the US federal. And what that test entails is a 4,000-pound crash sled at 40 miles an hour, hitting the bus in the angle side area of the fuel tank with a full load of fuel on board. And then after that, it has to be sealed for 30 minutes after test. So there could be no drop in pressure and there could be no leaks detected. And that's how you get a pass on that. And Propane Autogas, you can see the way that Bluebird integrates those tanks into their chassis. They're behind the axle, they're between the frame rails, and then they have angled plate steel that protects those tanks in there, not to mention the strength of the tanks themselves. But it's one of the most robust fuel systems that you can get on a school bus, period. So overall, when we're talking about school bus fleets, there's some things that we really hit on, which are a simple and robust design. We don't have the duty cycle compromise of other alternative fuels. You can just plug a propane bus in and do your routes. Economical operation, we can save the fleet money without any grants or incentives. It's safe by composition and design. So the fuel is safe, but also the design of the system makes it even safer. And then it's environmentally responsible from well to wheels. We can reduce one of the most harmful outputs that's dangerous to human beings, which is NOx, by a drastic amount by going to propane autogas. And then we also have a complete team in place to support the vehicle and the deployments after the sale. And I think this has been a big thing missing in the alternative fuel world, where vehicles have been sold by startup companies, and then it's really like, okay, now you're on your own to figure it out. We've got the power of Ford and Roush behind us, so when we have issues, we're able to have a hotline where we have field service engineers at the ready to talk through issues. We've got parts managers, we've got parts inventory, all these different things, along with a complete trained dealer network to be able to support the deployments and give you what you expect or better than your traditional fuel powertrains. That should be the standard for us to set, and that's what we go for. So shifting gears, what's the opportunity with CHS and Roush when we look at the school bus fleet? Well, let's look at some general overview. So we've got room to grow. Today we're selling somewhere around 20% of Bluebird's build, and of course we're only on that application. If you look at overall, we're somewhere around 5% of the total buses sold are being propane right now. But if you look at how many units are sold or available to us, considerably more, right? If you're talking about a couple thousand propane school buses sold a year, while the ceiling's all the way up, it's somewhere right around 30,000 units a year right now. So even though we're seeing propane school buses pop up everywhere, and it seems like there's a lot of stories with them out there, there's so much more for us to go after as a team or a group. So we've made a huge splash in this industry. It's the biggest fuel movement in school bus, period. But when you look at how much room we've got to go, there's plenty of opportunity for us all out there to get a lot more of fleet business from these schools. And that's really indicated here with the growing demand. So if you look at just the propane school buses Bluebird and Roush have put out and how many gallons those vehicles are consuming, you can kind of see this hockey stick heading up here to 2018. So those vehicles in 2018 accounted for somewhere around 34.5 million gallons of propane consumed across North America. So just that little segment and that growing demand, to see what it's done since 2016 is really awesome to see. The other part, which I think is really important for you, is the loyalty factor behind this product. It's the most loyal fuel type in the industry, which means that 82% of people who buy propane, their immediate following purchase is also a propane bus. So that is extremely high. If you look at the industry average, it's somewhere down around 30% loyalty rate. So it's almost triple the loyalty of a traditional product. And that's because of all those things we talked about. Start saving the customer money, simplifying their operation. The vehicle just starts and does its job without many headaches. They stick with the product. Now, for the people who didn't buy on that second one, the 18% that didn't, that factor includes people who bought a rear engine bus the next year, which propane's not offered them because they needed it for a trip or something like that. So really, when you factor all that in, it's even higher than that. So, which is a great thing to see. It's an extremely sticky product from a customer loyalty standpoint. So what should our market strategy be? The general gist of the sales process would be that first thing we need to do is really introduce propane as an offering, make sure that there's an awareness of it. Believe it or not, there are still a lot of districts out there that really don't have a good idea that that is an offering in the school bus industry today, and that they can adopt it as a fuel in their own fleet. So then we'll spend time qualifying the customer, gathering data, making sure that propane is a great choice for them. And propane really as a fuel ends up being a great solution for a lot of fleets. It doesn't have to be a fleet of high volume. It could be a fleet of 5 buses total. Propane can still make a ton of sense for them, just like the districts with 500 buses. And we've got customers that are running successfully in both of those categories. Education. So this is a big part where the fuel provider is so critical. Not only on the bus, and that's really our side, but the infrastructure side. So the immediate questions you get following, hey, I like the product, the vehicle ran great, how do I get fuel into it? That's where we really need educated experts like the CHS group to be in there with us to help us field those types of questions. That's where you guys take over and talk to them about code with it, how many gallons per minute, what the requirements are, what contracts look like, what do you recommend for locking in fuel, all those different things that a good propane provider brings to the table are crucial for the success of this whole thing. And then finally, going to the board and getting approval. And usually you get a lot of questions there about, what is this and how is it all coming together? And we kind of go over the material that we just shared with you. So critical factors for success, bus demos are absolutely critical. So, and having a knowledgeable fuel provider there at the demo is also critical. So to do those things, ideas on tank placement, turnkey solutions are absolutely from the fuel infrastructure side important. So helping with permitting, placement suggestions, making the solution on the fuel side very easy has just been very popular. Of course, no surprise there with school districts. And then also low to no upfront costs on the fuel stations, where basically that's absorbed into the price of the fuel, is also the favored method with most school districts, where they sign a contract, the fuel tank shows up and they start pumping fuel. That has probably been close to 80% of the experience that I've had has been that way. Other things that we've done that have been really successful is having one of the provider bobtails at the demo for refueling demonstrations, and also showcasing how portable the fuel is and that it's easy to get there. Pictures and blueprints of typical station configurations has also been helpful. And then offering the fuel nozzles 1 3/4 and Stably at the demo to showcase how simple fueling can be and kind of demystifying that for the customer. When you look at all those different motivations for the school district, this is kind of boiled down what we talked about, right? There's the environmental impact that we can have, which for a school board and a community is very important. That's why we put the green bird logo on the propane powered buses. The simplicity, so reducing the amount of maintenance, the number of diesel mechanics that a school district has to have, which are, in very high competition right now. The ease of integration, just being able to get started with it without making a ton of change to your operation or your facilities. And then the economics, that big one, where we're actually able to reduce that cost per mile considerably by switching away from the traditional fuel. The last thing that I'll share with you is just that we are here to help. Roush and the support team that we have, we've got territory managers that cover, and you can see the map there, the different parts of the country in Canada. And wherever you are, if you engage us, and you can reach out directly to me and I can connect you, but we've got connections with the schools, with the dealers that represent the area. We could get you tied into when we're having demo activity so that your people can be out there with us. We can connect you with the dealer so you can make an introduction and make sure that you're front of mind for them for fuel providers, or even share with them what you offer on the fuel side. And then we could also recommend your company. I mean, the big thing for us, we only recommend the fuel providers that we know are going to do a great job for us. And usually when we make the recommendation, they stick with that recommendation pretty closely. So we want the customer to have a great experience. Unfortunately, all too often, doesn't matter if it's infrastructure or maybe they bought a different school bus propane fuel system other than what we offer. They had a bad experience with it and they just bucket it all together with propane, and they just say propane was bad altogether. We're going back to diesel, and they just throw the baby out with the bathwater, so to speak. So it's really important that we both bring the best players with us. And, CHS has been a great player for us out there where we've worked with them in the Dakotas and Minnesota and some other places. So with that, I want to thank everybody for being on the webinar, and I will open it up to any questions.
Hey, Ryan, this is Ken again. And so, hey, appreciate all the information. It was really great. I do have a number of questions I'm going to throw at you and let you answer that have been taken online. So we'll go through those here right now. But just kind of a refresher or a reminder to everyone that's on the call. Don't forget also, as we're looking at school buses, that CHS is offering support for propane powered school buses through our propane powered program. So we're offering up to $2,500 per bus, up to 10 buses for each marketer that's doing business with CHS and has dollars available through the propane powered program. So keep that in mind. And then some of the questions that I've gotten, I'll just kind of go through them one by one, Ryan, and kind of just let you address them as we kind of go there, if that's okay with you.
Perfect.
First one's going to be where's the pressure relief valve on the bus?
So the pressure relief is located, so the valve is tank mounted, and it's got a shear point within the tank. So if anything were to happen there, it would not release vapor or fuel of any type. But that fitting is plumb then to the street side of the bus, into the skirt of the bus, and it's aimed down and away from the vehicle. So it has a valve that's tank mounted, plumbing that takes it all the way out and away. And the idea there is that in the event of a vehicle fire or anything like that, that it's venting down and away street side in the same exact location, which is visible from the exterior of the bus to anybody, first responders and that. That would be unique. The other school bus manufacturers don't necessarily follow that. So that would be a Roush Bluebird.
Okay. I got a couple questions, and I'm not sure if you're going to be able to answer these because these might be more of a Ford question than a Roush question. But maybe you've got some just ballpark numbers that would work out here. But what's the difference in price to buy when you're looking at a diesel versus a propane power bus?
Typically diesel versus propane just depends. It's market to market. It changes a little bit. But I would say a pretty fair average today is between $5,000 and $8,000.
Yeah. So
the propane would be $5,000 to $8,000 more than a diesel.
Okay. So this kind of fits right in there, and this one I don't think you'll be able to answer, but I'll throw it out there just in case if maybe somebody from Ford gave you this answer. But so with engine components so much less in cost, you know, comparing propane to diesel, the question is why are propane buses more expensive?
Well, if you look at a propane bus versus a diesel bus, you can't just look at the engine. You've got to look at the fuel system, the engineering, the crash testing, and all that validation that goes along with the complete propane system. So if you look at that versus how many diesel units are sold, and you try to look at justifying and absorbing all that spend over the units, you'd be looking at trying to absorb the spend, a similar spend on both, but one over tens of thousands of units and one over a couple thousand units. So as we've gotten further along, so if you go back to 2012 when we launched, the price difference from a diesel to a propane was somewhere around 10 to 12,000 more. And so as our volume has increased, we've been able to stair step that down to the 5 to 8 that you see today. Now, on the opposite side, what I'll say is that even with it being 5 to 8,000 more, we could recoup that cost for the typical district within 2 years or so. And the best part of it is we don't keep gouging you like the diesel guys do, right? They put all that extra componentry on there. Well, they're not just selling it to you once. They plan on selling that to you again and again and again, right? You bought that first turbo, but they're gonna get another turbo out of you, probably an EGR and all of that too. But to answer the core of the question, it would be really the scale difference. When you look at a medium duty 6.7 liter Cummins and how many different applications that whole thing gets put into, the volume there is tremendous.
Okay. Question here is a gentleman can't find a shop that'll work on propane powered buses. How do you guys typically handle that?
So from the Roush perspective, anytime we get notification that a customer is going to be taking delivery or is ordered a complete vehicle, a school bus, we do a perimeter search of their location. So we'll look in a 50-mile radius of where they are to look at potential shops. And then we will go through and start doing the due diligence of calling them, finding places that have the physical space to be able to handle, you know, a vehicle that's 40 feet long and 10.5 feet tall. And then once we do that, we'll find people that have the appetite or interest to work on a propane powered vehicle. A lot of times there's a lot of misconceptions out there about what propane autogas is. It's very similar to gasoline fuel injection. A lot of people hear alternative fuels or hear propane and automatically associate it with compressed natural gas, which is a totally different animal. And they just automatically say no. In a lot of those cases where we've gone back to say, do you understand, you know, the system completely, or could we walk you through that? Once they realize it's a lower pressure liquid injection system that has a maximum working pressure of around 350 pounds, they get pretty comfortable with it pretty quick, and they understand it's a spark ignited engine, simple Ford level tooling for scanning OBD2. So diagnostics and troubleshooting are really easy. And we've got everything from Bluebird dealers to Ford dealers to third-party independent repair facilities that are doing these repairs and have become warranty shops for us. So that's our typical process. But if someone has a specific need to get them repaired, they can absolutely reach out to us and we can help them in their area.
All right, that sounds great. I think that addresses most of the questions that I've gotten here so far. So with that, I want to thank everyone for joining our webinar today. I want to thank Ryan for taking the time to stick around, answer some questions, and give us a lot of really, really good information on propane-powered school buses. With that, I want to thank you and hope everybody has a good day.
Thanks, everybody.